I thought I will do a little talk on our testing tutorial that we did in the previous week. So one of the tasks we had was to develop test cases for a system that determines the type of triangle. So this task, basically we start off with a use case. So this is a very simple system. It only has one job to do, and that is to tell us the type of a triangle. So if we open up the use case and look at its notes, we can see a description for how this functionality works. So we have a simple function that helps the user determine the type of triangle. We have three possible types of triangles: equilateral, isosceles, or scalene. Valid sides can be represented by numbers from 1 to 99. Okay, so valid inputs are three numbers ranging from 1 to 99. Now, depending on what values we enter, the system will then display the type of triangle. So if the sides of this triangle fall outside of this range, the system will display invalid input. So if we would enter a number, let's say 200, which is outside of this range, that's not valid input, and the system would display invalid input message. Okay. Another possible error is if we enter three numbers which are in a valid range but do not constitute a triangle. Okay. So if we switch back to my notes, remember that the key points I was trying to make is that testing is time consuming, as you'll be able to see from this very simple exercise. And in order to achieve good coverage, we need to apply logical thinking to derive well-designed test cases. So let's move on to the anatomy of a test case. So we said test cases are used when we want to do structured testing, right, rather than ad hoc approach to testing. So if we plan our testing activities, we need to have a set of test cases that we will execute as part of our testing activities. We will record the results for those tests and then act depending on the results. So if the results are okay, the tests have passed, then we can be sufficiently assured that the quality of our system meets the specifications. Otherwise, if we discover any possible issues or if our test cases fail, we need to decide whether we will take corrective action. Okay. So when looking at a test case, the anatomy of a test case, each test case should have a test name. A brief description is also very useful. A brief description would tell us what the purpose of the test case is. For example, it could describe what kind of functionality it's testing and why. It absolutely needs to have test input and actions to perform as part of that execution of the test. So when we give our test cases to someone to execute them, they need to know what they need to enter into the system and what actions to perform as part of the test. And then lastly, it needs to have expected output, or also sometimes called acceptance criteria. So these are the results that we compare to our actual execution results. Okay. So if we ask someone to execute a test case, they need to have criteria which allow them to determine whether that test case was completed successfully or unsuccessfully. Okay, so this is defined in the expected output or acceptance criteria. For example, if we have a login procedure and our test case input is to enter valid user credentials and attempt to log in, then the expected output or expected result is that the system will allow the login. On the other hand, if our test case is to enter invalid user credentials, the expected output in this case is for the system to reject the login. Okay. So let's get back to our triangle case deconstruction. So remember, we have 5 possible outputs. I'll write that down. 5 possible outputs. And these are, the system could say that the triangle is equilateral, isosceles, or scalene. It could also say that we have entered invalid input, or that the numbers we entered do not constitute a triangle. 5 test cases because we want to test our system whether it works correctly under all these criteria. Okay, So if we move on, for equilateral triangle, remember this is a triangle which has all sides the same, what are some possible inputs that we could enter? The first one that I can think of is just three middle range numbers. So the valid input is from 1 to 99. So if we, let's say, entered numbers 50, 50, 50, that would constitute equilateral triangle and would be medium size based on the valid inputs that we can provide. Okay. Same with the scaling for isosceles triangle. So this is a triangle that has two sides the same and the third side is not the same as the previous two. So let's think about the possible input values we could use to test this case. So if we entered 50 and 50 for the first two sides of a triangle, we could then enter, let's say, 20, so a slightly smaller number for the third one, and this would constitute an isosceles triangle with all sides in the valid range. Okay. Now let's move on to scaling. So scaling triangle is a triangle which has all three sides different to each other. So, let's think about this. If we started with the first side, 50, and the second side, let's say slightly larger, 60, could we say that the third size could be 40? So 50, 60, 40, is this a valid triangle when it's scaling? I think so. Okay. What about some possible values for invalid input? So remember, we have a range of valid options which is from 1 to 99. So there's a number of ways we could provide invalid input. Either all of the sides of triangle could be invalid input or just one of them, and also invalid input would be any value lower than the valid range or any value higher than the valid range. So anything less than 1 or anything more than 99. So if we think about the actual values, this could be 0, 0, 0. That's very invalid. There's no way this could constitute a triangle, right? And if we try to enter the next invalid input, which is above the valid range, we could try 100, 100, and 100. Okay? So this would be a valid triangle otherwise, but our system does not accept these values as valid. Okay, let's inspect some other possible options. It could be that we enter 50, 50, and then enter 100. Right? While the first two values are valid, the last one isn't. Okay, so the system here would also display invalid input. Similarly, if we entered 50, 50, 0, that's also invalid input. Now, to add a bit more complexity, we could insert the invalid number at any position. So for example, we could say 50, 100, 50. That would still be invalid. Okay? So as you can see here, there's many cases, many combinations of input numbers that would constitute invalid input. So we have to make a good choice in our selection, because obviously we cannot import all of them and test all of them. Okay, let's move on. So if something is not a triangle, imagine we enter valid numbers in the valid range, but they do not constitute a triangle. So let's think about this. Perhaps if I enter 10, 20, and 90. Okay, so this would be a triangle with two sides which are very short and one that's very long. So there's no way these could meet up in a triangle. Okay, again, for not a triangle, there's many different combinations of values that do not constitute a triangle. So which one do we pick? So the smallest one, for example, would be if we look at the values in the lower end of the valid range. If we start with a 1 and a 1 and 3, that's not a valid triangle, and it's a very low, constituted of very low values. Similarly, if we look at values at the upper range, if we entered let's say 99, and then one perhaps. Oh, that's not gonna work. 99, 1, that would still work. Okay, so that's not a good example. Okay, possibly we need to have values which are below 50, below half, so perhaps 40, and something that's above 80, so 81. Okay, again, that would not constitute a valid triangle. Okay, think about all the possible values that we can input. So for the first side of a triangle, we can enter 99 numbers. For the second side of the triangle, we can again enter 99 numbers, and for the third side of the triangle, again 99. If we multiply this based on, combinatorics, we get a pretty huge number. So there's 970,299 possible combinations of values that we could enter, and some of these constitute equilateral triangles, others isosceles scaling, and some are not triangles at all. So this is just for the valid input options. Okay, then if we look at possible combinations of numbers for invalid input, it's any value that's lower than 1 or higher than 99. So since numbers are infinite, basically the space of possible values that we can enter is infinite. So there is absolutely no way that we can experimentally fully test whether this system works for the entire range of possible values. Okay, so let's go back to our possible inputs. So equilateral, we have 50, 50, 50. So this is some mid-range triangle. For isosceles, we have 50, 50, 20, again mid-range, and scaling 50, 60, 40, mid-range. Now here, for invalid input, we have already 5 combinations. So which one would we use for testing? Is it enough if we use one of them, or should we use more of them? I would say, as a minimum, we would have to test combinations in which all of the numbers are from the invalid range. So, for example, 0, 0, 0. But we should also test 100, 100, 100. So one that's below the valid range and one that's above the valid range. And as a minimum, we should also test some combinations where only one of the 3 numbers is invalid. For example, this one. So 50, 50 is valid, 0 is not. Okay? So we have 5 different test cases. Oh, this one is 100, so also invalid. Okay. For not a triangle, again, we have a large number of possible combinations. We should test at least one for starters. So for example, we could try 1, 1, 3. So let's have a look at this. 1 test case, second test case, third, then we have 5, so we're already at 8 test cases and 9 test cases. Okay, that's just for a very, very simple piece of functionality to achieve good coverage. Okay? So the point of this deconstruction was to show that we need to apply logical thinking in a sense that we need to identify possible outputs of every piece of functionality in our system, and then determine what constitutes valid inputs and invalid inputs, and come up with a good set of possible combinations of what we can enter as inputs to provide us good coverage. So as a minimum, we want to have 1 test case to test each of the possible outcomes. So the absolute minimum for the triangle example would be to have 5 test cases. 1 for equilateral, 1 for isosceles, 1 for scaling, 1 for invalid input, and 1 for not a triangle. Okay, enough of me talking about this. Let's actually go in and have a look at how we can enter test cases in Enterprise Architect. So you already received this pre-prepared starting file just to get you on the road quicker. So it's very simple to define test cases in Enterprise Architect. If you're looking at a use case diagram, you will notice in the toolbox that you have an element called a test case, which you can drag and drop to the diagram. Okay, I will just hit OK for now. So I want to indicate that the piece of functionality that I'm testing is actually this determine triangle type. So I will link the test case to determine triangle type use case. Now, I'm not really sure which of these connection types to pick. It's probably best if we pick one that's fairly generic, such as trace. For example, this tells me that a set of test cases I will define here can be traced back to determine triangle type. So the reason why I'm writing these test cases is to test determine triangle type. Okay, next, what I will do is bring up the testing view in Enterprise Architect. So first, I selected a test case element, then I go to element in the menu and bring up testing. Notice that you can also use keyboard shortcut called Alt+3. Okay, so this will bring up this extra tool up, and I like to pin it at the bottom of my screen, just so that it stays visible at all times. Okay, nice. So the way this works is you need to select whichever element you want to add test cases to on the diagram, and then you start entering test cases here. So for example, the first test case, I'll give it a number with some sort of prefix just to allow me to make sure that all the test case names are unique. And the first test case I will write is the one we agreed on for equilateral basic. So this one. Okay. So the description for this test case would be test basic equilateral triangle. Now in the input we agreed that we'll enter 50, 50 and 50, and our expected outcome or acceptance criteria is displayed result is equilateral. Okay, we can ignore the results tab for now. This tab in Enterprise Architect is actually intended for when you go and execute the test cases on the real system. So the tester would execute test case as described in the input, compare the output to the acceptance criteria, and then note down test results in this tab. So for example, they could mark the test case as passed, failed, deferred or cancelled. Mainly pass and fail. Okay, so I will save this test case now and it appears here. Okay, one thing to note here is I've accidentally entered this test case under the unit tab rather than integration system or acceptance tab. Now, I would say this test case, this particular test case, is a system test case because we're testing the triangle system as a whole. So just what I'll do is I will right click on this test case and I will say I want to move to a system testing tab. Okay, so if I go to system tab, it's now appearing here. Okay, let's add another test case. So I'll just click on the new button and we have TSD 002, and I think we agreed to test isosceles triangle. So as input, we will enter, what were the values? So there are 50, 50 and 20. 50, 50 and 20. And the acceptance criteria, system displays okay, good. Next one. So scaling triangle is next. So we agreed to enter these numbers, 50, 60 and 40. And the result should be a scaling triangle. Very good. Forgot to put description. Very good. And I will save this. So now we have a collection of 3 test cases here. So only 3 for now. But what I want to show you is how you can make these appear on the diagram as well. So in the test case bubble, what we can do is right click on that test case bubble, go to advanced, and select the option to show rectangle notation. Okay, that's step number 1. And then I will right click on a blank area in the diagram, go to properties, features tab, not features, elements tab, and tick the testing option. Okay, very good. So we can now see these test cases displayed on the diagram as well. Okay, but that's not all. What you can do, and you should do for your group assignment, is export these test scripts. So we go to our project browser, we select the package where we have our test cases defined, which is exercise 1 for us. We right click on it and go to documentation, rich text format. So what we can select here is testing template, and I'll just make sure I generate them in this folder that I prepared, and I will call this test script RTF. And we can now see these test cases that we defined. So we have the names here, we have a description for each of the test cases, including the input that the tester is supposed to enter when conducting testing, the criteria against the results of the testing are to be compared to, and status details, right? So we could print this out, give it to our tester, and ask them to execute testing on the system that we've developed, and they could report the results in the last column. And we could use that to evaluate whether we've done a good job with the implementation of the system. Okay, so what you need to include in your assignment is a diagram, such as this one. So it needs to show the overview of test cases, and the test cases need to be linked to appropriate other element. You can link them to use cases, or you can link them to requirements elements. And the second thing you need to include in your report is this section. So a printout of the test cases, because these details are not actually visible on this diagram. Now I'll just show you a little trick. If you are using a requirements diagram, or add one, a basic requirements diagram. So if we imagine that we're still testing this triangle system, one of the requirements would be for the system to display system determines the type of triangle. So that's a requirement of the system. So if you wanted to define test cases for a requirement, what you can notice here in the toolbox, you can't actually see that test case bubble. Got a quick way to get around this, and simply to drop your requirement onto a use case diagram. You want to do it like this. I'll do it again. So I'll paste it as a link. Okay, so if I wanted to connect the test cases to requirement, well, I can simply do this. So I will trace it back. Okay, so that's one way. Really, if I go back to the requirements diagram, if I add the test case element back onto the diagram, not as a link, but as a link, you can see that the connection that I created in previous step is also automatically added. Now, for better organization of our model, what I would also do is rename this element to something that's more descriptive. So that would be triangle type test cases. Good. Okay, that's all for today.